right, so let's finish up this worksheet. Here is our next compound. It gives you a little hint saying carbon is central, but at this point we should know carbon's always going to be our central atom. So I'm going to put that right in the center. And then we've got 2 hydrogens and 1 oxygen. So I always like to deal with the things that make symmetry easy first. I'm going to just put my hydrogens on left and right. And then I can either put oxygen on top or bottom. I'm just going to choose top right now. And I'm going to also just move this down because that is a little tough on space. Okay, so here we've got the basic outline for it. I have got 2, 4, 6 of my valence electrons in the picture. I'm going to add the last 6, and since hydrogen already has a full valence, I'm going to focus on oxygen. And so now I've got, let's just count it out, 2, 4, 6, 8, 10, 12. Perfect. All of them are there. However, we come to the same issue where my carbon, the central atom, doesn't actually have the right valence or the right number of bonds to it. So again, we just kind of look at some of the extra non-bonding pairs of electrons on oxygen. We can also quickly do some Lewis dot diagrams to figure out, hey, wait, how many bonds should each of these have? Oxygen needs 2. Carbon, of course, always needs 4. So I'm going to take those highlighted valence electrons and put them down into a bond between oxygen and carbon. That would give carbon 4 bonds and it would give oxygen its 2 bonds it needs. So I'm going to erase those guys. I'm going to just put that second line there. And we're done. So I did C2H4, which will come in screen in a second. And I kept off carbon dioxide only because I had that in the other video. Don't want to kind of redo everything. So right now let's focus on C2H6, dicarbon heptahydride. Carbon's always central. Since we have 2 of them, I'm just going to put them right next to each other. And then we've got 6 hydrogens. So it's got to be symmetrical. And again, we just talked about carbon always needs 4 bonds. So I'm going to put 3 hydrogens on each carbon. We're going to go top, side, bottom, top, side, and bottom. Now, quick glance through. All of the hydrogens have a full valence. We don't have to worry about them. Both of our carbons have 4 bonds on them, so that means they've got a full valence and the right number of bonds. Our only real check here is just to make sure that we have 14 valence electrons on this compound. So we've got 2, 4, 6, 8, 10, 12, and 14. Perfect. I also wrote out these guys. Let me kind of zoom out so you can see it all. So C2H2, really the only difference is that we have way less hydrogens, which means that carbon still has to have those 4 bonds. And so we use all of our extra valence electrons just to triple bond in between them. And then this guy right here, I'm going to highlight because I realize that I can't point at my screen and you guys see it. That guy right there kind of just is the same as the one we just did, the C2H6. We've got 6 different ligands to put on, and the only real difference is that we had to give chlorine a full valence as well. And the number of electrons present for us allowed us to do that. So now the last 3 are a little bit confusing. They take some understanding, or at least I understood it once I took organic chemistry, so we're going to talk about that. It's the way in which the compound is actually written. So for this guy, we see that it has our carbon, 2 carbons, and then 5 hydrogens. And then for some reason, though, we split up a hydrogen and put it right here. When it is written like that, it's trying to tell us, hey, that particular hydrogen is actually attached to the oxygen, not onto one of the carbons, just onto one of the oxygens. So I'm going to just start setting up. I'm going to put carbon and carbon next to each other. Always a good call. And then I'm going to put those 5 hydrogens on first. So similar to what we've been doing, I'm going to put them top, side, and bottom. Here I'm just going to put them top and bottom, right? Trying to keep as much symmetry as we possibly can. That leaves us with this carbon right here needing 1 more bond. And that works really well since we have this oxygen to put on. So I'm going to put my oxygen right here. And then we see that our carbons are totally set up. Our hydrogens are totally set up. But our oxygen here really wants another bond. We have done that Lewis dot diagram of a bunch. We know it needs 2 bonds, and that's where that hydrogen comes in. Perfect. So now it's just, hey, we've got everyone set up with bonds. Do we have the right amount of valence electrons? Let's do a quick check. We've got 2, 4, 6, 8, 10, 12, 14, 16. So we do not have the right number of valence electrons on our molecule, on our Lewis dot diagram. And if we look at oxygen, you should recognize that, wait a minute, it's only got those 2 bonds, which means it only has 4 electrons on it right now. So I'm going to go through with my last 4 and just put them on oxygen. Therefore, it gets a full valence, and we've used up all 20 electrons available to us, no more, no less. Let's see if I can move it correctly. So the same thing happens here. We have this CH3, and then it's separated by an O, and then there's another CH3. It's literally telling us, hey, this is how to draw it out. It's going to go carbon, oxygen, carbon. Again, this is kind of knowledge you learn later on, but it makes it a lot easier, so I'm just going to share it now. So I'm going to do carbon, oxygen, carbon. Now, if you notice, the hydrogens right here are specifically attached to carbon. So I'm going to just kind of draw on those. I'm going to put 3 hydrogens on this carbon. And then on the next carbon, I'm going to do the same. So we've got all necessary elements put into this compound. Our carbons have the right number of bonds. The oxygen has the right number of bonds. Our hydrogens have the right number of bonds. It looks as though everything except oxygen has a full valence. One more time, I'm just going to check in, make sure I have enough valence electrons left over to put on oxygen. So we've got 2, 4, 6, 8, 10, 12, 14, 16. Perfect. That means I've got 4 valence electrons left, and my oxygen can have its full valence. And for our final problem, we've got CH3 and H2. It's pretty much still the same, right? This is trying to tell us, and the way it's spread out is trying to say, hey, this carbon is going to have 3 hydrogens coming off it. And then we know there's a nitrogen that's going to have 2 hydrogens coming off it. And since we don't really have a central atom, let's just connect these 2. Boom. Carbon's got 4 bonds. Nitrogen has got 3 bonds. I'm going to do the count through really quick. 2, 4, 6, 8, 10, 12. We have 2 electrons left over. And if you've noticed, nitrogen's the only one that doesn't have a full valence. So I'm just going to put those 2 last valence electrons on. We've satisfied basically every single rule we need to, and it's looking really good. And so that is kind of the harder end of Lewis dot diagrams for covalent compounds. And it's really just kind of learning how to read through different molecules and what it means.